Electron configuration, SP notation. Electron configuration is an important topic for a grade 11 learner, especially a chemistry learner, to understand how electrons are distributed in different elements, or to draw the Lewis dot diagrams, such as this is an important topic. So we have to understand how to write the electron configuration. Its another name is SP notation. Let's see the definition. Electron configuration of an element describes how electrons are distributed in its atomic orbital. So it shows how is the distribution of electrons among the atomic orbital, and there is an order, there is a pattern we have to learn. So to understand electron configuration, we have to learn about the octet rule. Octet rule. Octet rule states that atoms are more stable when their valence shells are filled with 8 electrons. In short, octet rule says that an atom is looking for 8 electrons in its valence shell to attain stability. Each and every atom or element is trying to attain stability. To attain stability, it needs 8 electrons. The elements that obey this rule includes S block elements and P block elements, except hydrogen, helium, and lithium. Since the first shell can only accommodate 2 electrons, such as hydrogen, lithium, and helium, obey the duet rule instead of the octet rule. That is a special case in chemistry. So we have to consider this hydrogen, lithium, and helium. They don't obey octet rule. To understand the concept of electron configuration better, let's have a quick look at orbital. What is an orbital? Actually, orbital is a space around an atom where you can see, most probably see an electron. An orbital is a three-dimensional description of the most likely location of an electron around an atom. So to find the location of an atom, we have to consider orbital. Orbital is a space. Let's have a look at s orbital. An s orbital is spherical in shape. The s orbital can contain up to 2 electrons. The maximum number of electrons an s orbital can have is 2, and you can have a look at the shape of the s orbital, that's spherical in shape. A p orbital has double teardrop shape. That shape is like this. If you consider this as a teardrop, then another teardrop join it. You can call it as a dumbbell shape. This is a shape of p orbital. P orbital has 3 subshells. They are px, py, and pz. These are the 3 subshells of p orbital. Then an important thing when you learn about p orbital is a p orbital can have maximum 6 electrons. It can accommodate 6 electrons. Actually, a p orbital has 3 subshells, px, py, and pz. And each subshells, it can accommodate 2 electrons. 2, this one 2, and the last one 2. So this, when you add these 3 electrons, you will get 6. That's the reason a p orbital can contain 6 electrons. Remember, s orbital 2 electrons maximum, and p orbital 6 electron. These are the diagrammatic representation of a p orbital. Let's have a look at it. This orbital is along x-axis, that this one is px. This orbital is along y-axis, this is py. This orbital is along z-axis, this is pz. That's a small description about p orbitals. And now let's have a look at the order of orbital. We have to learn about the order of orbital. This is the order of orbital around the atom. The first orbital is 1s orbital. The second one is a 2s. The third one is 2p. And fourth one is 3s. It goes like that. And I am trying to teach you until 4s orbital. If this is a nucleus of an atom, nucleus, the 1s orbital is around the nucleus, that is close to the nucleus, that is the first energy level. You can say that that's the first energy level. The second orbital is around it, that is the second energy level, and it goes like that. So when you see this 1s, you have to know that its energy level is 1. 2s and 2p, they are together, so they have the same energy level. So when you count the number of valence electrons, you must include 2s and 2p together. 3s is the next energy level, and 3x comes along with 3p because they have the same energy level. 4s comes along with 4p, 4d, and 4f. It goes like that. Let's have a look at magnesium element. Magnesium element is represented as Mg, 12 on top and 24 at the bottom. The smallest number around an element shows atomic number, and the large number shows atomic mass. So atomic number for a neutral atom is the number of protons or the number of electrons. Here we only consider the number of electrons because we are dealt with the electron configuration. So we have to put the 12 electrons in this orbital in the correct order. I wrote the orbital in order: 1s, 2s, 2p, and 3s. The first orbital is s orbital. The maximum number of electrons could accommodate in s orbital is 2. So s orbital can have 2 electrons. This is 1s2. Then second orbital is 2s. Again an s orbital. It can accommodate 2 electrons. The third orbital is 2p. P is the orbital which can accommodate 6 electrons. So I put 6. Let me count the total number of electrons that I already distributed. 2 plus 2, 4. 4 plus 6, 10. I already distributed 10 electrons and I left with 2. The total number of electrons are 12. I distributed 10 electrons here. Now I left with 2 and 3. This is 3s orbital. It has 2 electrons. And 3s is a different energy level. So the first energy level, second energy level, and the third energy level. And this 3s orbital consists of 2 electrons, and that is the valence shell and the valence electron. So here you have 2 valence electrons, and the rest of the electrons here you can see they are core electrons. Then the correct electron configuration for magnesium is 1s2, 2s2, 2p6, and 3s2. You can see that 3s is a valence shell and it has 2 electrons. That is the number of valence electron. That's the reason magnesium falls in group number 2. Magnesium is in group number 2. You can see that it is in group number 2. Okay, let's have a look at chlorine. What happens with chlorine? Look at the chlorine atom or chlorine element. Chlorine is represented as Cl 17, 35,5. 17 is atomic number and that's a number of electrons. It has 17 electrons. I wrote the orbitals in order. The first orbital is 1s, then 2s, 2p, 3s, and 3p. I need to distribute 17 electrons among the orbital. 1s is s orbital. It can have 2 electrons. 2s is s orbital. It can have 2 electrons. 2p is p orbital. It can have 6 electrons. 3s is s orbital. It can have 2 electrons. 3p, we have to check how many electrons we have left with now. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12. We left with 5 electrons to make it 17. So those 5 electrons I put it here. The total number of electrons, if you count here, you can see that they are 17. Let's find out which are the valence electron and which one is the valence shell. Look at this is 1s, energy level 1. 2s and 2p, they are together, energy level 2. 3s and 3p, they are together. These two are the last shell and they are the valence shell. You must include the s orbital together with p because they have the same energy levels. Ne? So you can see that this one is the valence shell and your valence electrons are 2 plus 5, it's 7. That is the reason it falls in group number 17 because it has 7 valence electrons or oxygen atom. Oxygen, you can write it like 8 and 16. 8 is atomic number, so it has 8 electrons. So we have to distribute these 8 electrons among the orbitals. The first orbital is 1s2 is s orbital, it can accommodate maximum 2 electrons. The second one is s orbital, it can accommodate 2 electrons. We left with 4 electrons now. Total number of electrons are 8. We already distributed 4 electrons. Then we left with 4 electrons. And let's check the energy distribution and energy level. This is the first orbital, 1s2, and its energy level is 1. The second one is, there are 2 orbitals there on the second energy level, 2s and 2p, they are together because their energy levels are equal. Let's check how many valence electrons we have. We have 2 plus 4, 6 valence electrons. That's the number of valence electrons. So this is how we draw electron configuration of different elements or atom. That's all about today's class. I hope you enjoy it. Thank you.